Japanese soldiers described the Second World War as a steel typhoon. In this storm, Akio Morita, a young engineer from a wealthy family who was assigned to the Japanese Naval Engineering Laboratory during the war, was lucky enough to avoid frontline combat. But with the attacks of American B-29 Superfortress bombers, his hometown and other Japanese cities suffered a devastating blow. By the end of the war, his brothers were even training to become kamikaze pilots. Across the East China Sea, Zhang Zongwu heard gunshots and air raid sirens from time to time during his childhood. He escaped fire from the Japanese army during the anti-Japanese war and moved to Guangzhou, Hong Kong, and eventually the wartime capital of Chongqing. After Japan's defeat, he returned to Shanghai, but the outbreak of the Liberation War made him flee the war again and go to Hong Kong. In Budapest, Andy Grove also experienced the horrors of war. His father disappeared during the Battle of Stalingrad, and he and his mother escaped being sent to a death camp when the Nazis occupied Budapest. The liberation of the Soviet Red Army allowed him to hear the sound of artillery again. The Second World War was a conflict of industrial attrition, with the United States manufacturing vast quantities of tanks, ships, and aircraft to provide critical material support to the Allies. The United States produced more tanks than all the Axis powers combined, and it produced twice as much aircraft and artillery. These industrial products are shipped around the world through U.S. ports, providing essential support to Allies. After the war, new technologies were also transforming military power. Great powers built thousands of aircraft and tanks and developed new equipment such as rockets and radar. The invention of the atomic bomb heralded the arrival of a new atomic age. During the final months of the war, Akio Morita worked on heat-seeking missiles. Japan is far from deploying usable guided missiles, but the project gives Akio Morita a glimpse into the future. He was vaguely aware of new developments in electronic computing that might allow machines to think by solving mathematical problems such as addition, multiplication, or finding square roots. The idea of using machines to perform calculations is not new. Ever since humans first learned to count, they have been counting by flipping their fingers up and down. The ancients invented the abacus to manipulate large numbers. For centuries, people performed multiplication and division by moving wooden beads back and forth on these wooden grids. The growth of large bureaucracies in government and business in the late 19th and early 20th centuries required large numbers of human computers, with office workers equipped with pens, paper, and occasionally simple mechanical calculators. As the need for computing continued to grow, engineers eventually began replacing the mechanical gears in early computers with electric charges. Early electronic computers use vacuum tubes. A vacuum tube is a bulb-like device with a metal wire sealed in vacuum glass. The current flowing through the vacuum tube can be turned on and off via control electrodes, not unlike the function of a bead moving back and forth on a wooden rod. An open vacuum tube is coded 1, while a closed vacuum tube is coded 0. These two numbers can produce any number using the binary counting system, so many types of calculations can theoretically be performed. Additionally, vacuum tubes allow these digital computers to be reprogrammed. Mechanical gears, like those in a bomb sight, can only perform one type of calculation because each knob is physically connected to a lever and gear. Much like the beads on an abacus are bound by a rod that moves back and forth. But the connections between the vacuum tubes can be reorganized, allowing the computer to run different calculations. Clearly, vacuum tube technology was too cumbersome, too slow, and too unreliable. As long as computers are moth-ridden monsters, they will be useful for only a few applications, such as breaking codes, unless scientists can find smaller, faster, cheaper switches.